Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. So, in this channel, what we are discussing all about quality control, construction, and the strategies how you can get success in your career. So, what is today's topic? Today's topic is about the concrete ingredients. But let's say it's a supplementatious, cementitious material. We are using fly ash, we are using GGBS. But what is the difference? What is the comparison in between GGBS and the fly ash? In today's video, I will discuss each and everything. So stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So what is comparison in between GGBS and fly ash? So before that, the concrete is a homogeneous material. It has concrete, it has coarse aggregate, fine aggregate, water, and admixture. And when they react and they make a hardened paste, that we call the concrete. So the concrete, lately we know only that the cement and the water. Now, after that, supplementatious cementitious material has been used in the concrete, such as GGBS, fly ash, metakaolin, alkofine. These are all different types of supplementatious cementitious material or the mineral admixture. Now, why these are using? Because it gives the strength as well as the durability, because we are making concrete not only for 1 days, 2 days, 1 year, 2 year. So the strength criteria as well as how it will withstand with the environment, that is the durability criteria, that also we are discussing or we are designing whenever we are designing for the concrete. So this GGBS fly ash or any material that is we are introducing other than the cement, it enhance the strength and the durability. That is why we are using GGBS as a part replacement of the cement, and it has huge impact on the concrete performance. So strength and durability increase. But there are different types of supplementatious cementitious material. As today I'm discussing only about the GGBS and the fly ash. So first things, what is the permissible percentage? Because this every supplementatious cementitious material we cannot use as whatever we want. The code has given the guidelines that how much we can use maximum. So here you can see in the table 9 of ISO 10262, it is giving the guidelines that fly ash can be used maximum 2015 to 30%. So it has given the limitation. So if we want to make a mixed design using the fly ash, we have to be keep in mind that it can be maximum 15 to 30%. We can replace or we can reduce the cement quantity. On the other hand, it is giving the GGBS, it is giving the higher level. It is 25 to 50% as per codal province. See, I have already discussed the another two, this metakaolin silica fume, that also you are using, that is a 5 to 15 and 5 to 10. But today I'm not discussing on this, but these are the mineral admixture that are using in the concrete to enhance the strength and the durability. But it has the maximum limit or the maximum percentage of limit what we can use as an admixture. So fly ash is 15 to 30%, whereas GGBS is 25 to 50%. Now, why this limitation has been given? Because it's, although it's giving the strength or it's given the durability, but what is their effect can be detrimental, or it react with the calcium hydroxide what is available in the concrete. Whenever it's cement react with the water, they form the CSH gel and the calcium hydroxide, so they start reacting with the calcium hydroxide. So if we are increasing, then it will be the less concentrated calcium hydroxide available in the concrete mix. And also the workability will be problem because it will be stiff, because it's a finer particle, and it has the higher water demand because the specific surface area is bigger or more than the cement, because it's a finer particle, and if the surface area is more, it's highly reactive and it's a more water demand. So it will be increase the water cement ratio, and again the water cement ratio is increase, it will decrease the strength and the durability. So that is why there is a limitation in the maximum allowable limit. So code has given the guidelines, and this GGBS has be used in a higher percentage. Fly ash can be used in the lower percentage. So these are the permissible percentage as per the IS code guideline. Now, what is the source of product? Fly ash, where we can getting, that is a thermal power plant as a byproduct. So coal, whenever the coal is hit in the boiler, so it's in the chemical process, it's bringing down, and it's called the fly ash. So it's a byproduct, and it's a pozzolanic material and gray in color. But on the other hand, GGBS we are getting from the iron or the steel industry, and also it is a byproduct, and it is a latent hydraulic material. So there is two extent, that's the pozzolanic material, and it is a hydraulic material. One can start reacting with the water, and if it is non-hydraulic, then it cannot work the water. So that's why we call the cement is the hydraulic cement, because it's a reaction with the water. So this fly ash is a pozzolanic material, and here the GGBS is the latent hydraulic material, and its color often is off-white and light gray in color. Both are the byproduct we are getting from the industry. Fly ash is for the thermal power plant industry, and GGBS from the steel and the iron industry. Now, these both are using as the raw material for the concrete. So if the raw material quality is ensured, the ultimate concrete quality will be ensured. That means concrete strength and durability will be ensured. So in order to get the right kind of concrete, we need to the right kind of the raw material. So whenever we are using fly ash as a mineral admixture or the GGBS, we need to check whether this product are quality product or not. See, in the fly ash is non-stringent and not very consistent and moderate reactive. But in the GGBS, it is very stringent and very consistent and moderate to higher reactive. That is why the GGBS has the given the higher percentage in the codal provisions, that we can use more than the 30%, about the 50%. But some concrete expert also saying that more than 50% can also be used, because it's a design mix. We can make the design whether it is accepting or not. But if the criteria is matching, we can. But again, the codal property is not given more than the 50%, but many concrete technologists or the concrete specialists, they are saying it can be increase further. So it's a very stringent and very consistent. So quality of raw material as the GGBS is the very stringent quality. So that is why we can rely on the GGBS. On the other hand, fly ash is a non-stringent and not very consistent. So for the quality of product, we can say we can use the GGBS. Now, what is the hydration? Now, hydration is means that concrete, whenever we are making, we are adding water into the mix. Now the cement is start reacting with the water, and we call the hydration process of the concrete. Now the fly ash is non-hydraulic, that means it will not react with the water. But on the GGBS, it can react with the water, that is why it's a hydraulic. Now that is a catch. So first the cement will start reacting with the water, and they will make the byproduct of the calcium hydroxide, and this calcium hydroxide will react with the fly ash. But on the other hand, GGBS can react with the water. So that is why it's a hydraulic reaction, and the fly ash is a non-hydraulic. So in the process of hydration also, GGBS has given the preference over the fly ash. Now the cost of product, of course, whenever we are making as a part replacement, we have to think about the product cost, because our project should be the economical projects, and it should be within the budget. So that is why we need to think about the cost. Now the GGBS generally costly 40 to 50% cost of the cement. So its cost is higher, but overall cost may reduced with higher percentage of GGBS. So if we are using higher percentage of GGBS, the overall cost of the concrete may reduce, but it has the higher cost, that is a 40 to 50% of the cement cost. So what are the cement cost? It's around 40 to 50%. But on the other hand, fly ash is generally cheaper, 20% cost of the cement. But as I discussed earlier, the fly ash quality is not stringent and can vary, but the GGBS is the very stringent quality, and it has given the preference over the fly ash. So the cost of product also the GGBS is higher, but is given the more preference because it's can be used the higher percentage. Now, mass concrete compatibility. See, what is the mass concrete? Mass concrete is a concrete of huge volume, so huge heat is producing. So, if the heat is more, then there is a possibility the thermal cracks can generate. So that is why our tendency in mass concrete to lower down the concrete temperature, the placement concrete temperature, core temperature, and the peak temperature, that we need to reduce it. So how we can reduce it? There are different ways. I have made a detailed video on the mass concrete. You can check, you will get the full information. But with the mass concrete compatibility, GGBC is higher mainly because of higher permissible replacement, and the fly ash lower mainly because of lower permissible replacement. So in the mass concrete also, GGBS has the edge over the fly ash because it's we can replace higher percentage and the heat of hydration is become less, and the fly ash is a lower percentage we can use, or we can replace cement with the fly ash is a lower percentage, so the heat of hydration is become less in the fly ash. But in the GGBS we are replacing more, so the heat of hydration will be less, will be more, so peak temperature will be less, and that is why GGBS is the number one choice for the mass concrete. Although we are using fly ash, but the temperature, core temperature or the peak temperature, if you are using GGBS, it has edge over the fly ash. So in the mass concrete compatibility also, GGBS has the better performance. Now the long term strength, GGBS is much higher than OPC as replacement is higher, when the fly ash lower as the part replacement is lower. So in the long term strength also, GGBS has the better quality in the concrete because we are replacing higher percentage of GGBS. So next is the segregation and bleeding. Now, these segregation and bleeding is the problem for the concrete strength as well as the durability. As I discussed earlier, the concrete, not only the strength, concrete durability is also a concern. We have to think both the concrete strength and the durability. The segregation is the separation of coarse aggregate from the mix, and the bleeding separation of water from the mix, and the both are is not good for the concrete health. It is deteriorating the concrete strength and the durability. So if you are using GGBS, is it enhance the concrete performance, so the segregation and bleeding percentage will be the less, and the fly ash is the lower chances. So if the we want to prevent the segregation and the bleeding, GGBS has the better performance over the fly ash. The next is the sustainability. Now, what is sustainability? That we all know, because the sustainability is that we are working in this Mother Earth and we are taking material or the raw material from the Mother Earth. So, at a time, the sources will be very limited. And whenever we are using OPC cement, then production of OPC releases the CO2 gas, that is the negative impact on the environment. So we have to think whatever we are using in our concrete, that should be sustainable or that should not harm our environment. So whenever we are using GGBS, it's a very high with high permissible per replacement, and the fly ash lower than GGBS. Now why? Because these both are the byproduct of the industry. Now, if we are not using, what will happen? It has to deposit it on the earth. Now, if we deposit it, the land quality, water quality, and the air quality will be contaminated. So, whenever we are using GGBS or the fly ash, whatever, we are actually helping for the Mother Earth. We are using the byproduct and we are helping Mother Earth to breathe. But GGBS we have the higher permissible limit, so that is why GGBS whenever you using, we are using higher percentage of byproduct, so it is giving the Mother Earth to breathe more. But in the fly ash it's a lower percentage, so it has the lower impact on the sustainability. And the chloride and sulphate attack, all we know that when a chloride is coming inside the concrete, it reactivate the passive layer from the river, and its river start corroding, and the corrosion of reinforcement happen. So GGBS we are referring, and the sulfate attack also, that is deteriorating the concrete, or it is also generate the cracks, falling, etc. So both the chloride and sulfate resistance is not good for the concrete health, that is the concrete strength and the durability. So if you are using GGBS, excellent in sulfate and chloride resistance, or on the other hand, fly ash, good in sulfate and chloride resistant, but GGBS is excellent. That also another reason that the GGBS we are using the higher percentage, but we are also using fly ash, that is also help us to reduces the sulfate and chloride attack, because all are making dense concrete, less permeable concrete. If it is dense concrete, less permeable concrete, what will happen, this chloride and sulfate and the moisture will not penetrate inside the concrete. See, without the moisture alone, this chloride and sulfate has no impact on the concrete, because it only react whenever the presence of the water or the moisture. So if the less permeable concrete, then there is a possibility of the less chloride and sulfate attack. And GGBS is has the excellent property, and fly ash has the good property. And what is the initial and total creep? The creep is the deformation under the sustained load. So GGBS is far less with permissible high percentage of GGBS and small percentage of UF, that is use foundry sand. And on the other hand, the fly ash more than GGBS with high permissible percentage of fly ash and small percentage of UFFA ultrafine fly ash. So the initial creep and the total creep GGBS is less, but in the fly ash is the more, because it's a high percentage you are using. So the creep is also a problem for our concrete, because under the sustained load it can deform. So whenever you are using GGBS, we are helping our concrete to counteract this creep coefficient or the creep load. So in this way we are helping our concrete, or and the same way we are helping our mother earth by using the fly ash and the GGBS. Both are mineral admixture, and both has the effect on the concrete strength and the concrete durability. So I hope you find it useful, and if you find it useful, can you subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comments, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.